Okay, and good afternoon or good morning, depending on what time you're watching this video. This is the Q&A session covering webinar 4 in invasive species, which was UK and Ireland native invasive species, the importance of biology. The webinar was presented by myself and Dr. Dan Jones from Advanced Invasives. Like we mentioned in the webinar, there were a couple of questions we didn't quite get covered, and also some that we've revisited to go into a little bit more detail because time during the webinar didn't permit us to go into that detail. So what we'll do, we'll go through these questions one by one. There's only a few. Dan will answer them and hopefully give you the answers you need. If not, like I said during the webinar, you are very welcome to make contact with either myself or Dan, should you want any more information. Okay. Question 1, Dan. This is from Peter Fitzsimmons, and he asked, how does Icate manage to get into the rhizome network to affect long-term control?
I think the best way of viewing this is that Icate and the other synthetic auxins, so as I understand it, you've got MCPA, 2,4-D, triclopyr. There may be others that are effective at poisoning the above ground parts of the field horsetail plant. And what we're trying to do is burn those parts of the plant off using the synthetic auxins in order to allow competition from other native plants. So I don't think the synthetic auxins get that far in the rhizome system, and certainly looking at Japanese knotweed as a model system, with the exception of picloram, so tordon, none of those products affect long-lasting control, or certainly nothing equivalent to what you get with glyphosate-based management. So I think it's less about, uniquely from the rhizome species that I've been talking about previously, field horsetail isn't about targeting the rhizome as much as getting rid of the above ground biomass as quickly as possible and as cheaply as possible as well.
Okay, Peter also came back with another question again on field horsetail. This one says, does silification of the green parts increase over time? And if so, wouldn't an earlier treatment work better in terms of uptake?
Absolutely, and I think this is an interesting one. The advice is based on source-sink relationships as they're understood currently with field horsetails. This later season application is kind of analogous to what you get with the knotweed, you know, the late season drawdown of resources down into the rhizome system. But I think, based on what I just said about the Icate as well, this treatment to remove the above ground biomass could get started earlier than is currently recommended, but we don't have any information to support that at present.
Thank you very much. Now, one question that we briefly covered off in the webinar, but I know that you want to revisit again because you've had a separate conversation. This was originally from Richard Wheatcroft, and he said, what is the evidence for toxicity to grazing animals, especially after baling? Does it become more potent when dead like ragwort?
Well, Brian Taylor from the Japanese knotweed company actually got back to me on this the day after, and he's provided me with a really good explanation of what goes on with this. So he said the toxicity of ragwort and other poisonous plants such as field horsetail to grazing animals is well known. What is less understood is that susceptible grazing animals generally avoid eating these plants when green. They are not palatable to the animal and so are usually avoided. Problems may occur, however, when these plants are dried, either as part of a haymaking process or through the use of herbicides or otherwise preserved, for example, silage, at which point the plant matter becomes more palatable and poisoning of livestock may well result. Spraying contractors should note that use of herbicides in pastureland or hay meadows must be made with caution, as if poisonous plants are sprayed, either deliberately or by accident, then animal poisoning or death may result and a legal liability could be established as a result. As a bit of extra background, sheep and goats are generally speaking less susceptible to ragwort and may even browse minor infestations when they're green, but can still be poisoned by dried preserved ragwort as they overeat it. So I think that's a pretty comprehensive answer, and certainly more detailed than I was able to provide.
Thanks very much, Brian. No, that one covers that one off. That's perfect. Okay, so a couple more that we touched on again, but I know you again want to go into a little bit more detail. One was from Keith Gallagher, and it refers to carrying out or controlling field horsetail by controlling the pH of the soil. To summarize a rather wordy paragraph that he'd written. So basically how it, manipulating, is it possible to manipulate the soil pH to control?
It depends on the context. There is a possibility that that can be manipulated under certain conditions. Certainly with respect to the field horsetail on the site I was working on this year, there was a possibility of improving drainage, which would have reduced the abundance of field horsetail. So Keith's got it. Like this is the point of integrated pest management. You know, if you can manipulate the conditions to make them less suitable for the growth of invasive weeds, native or non-native, that means that you don't have to manage them in the long term. So there's great benefits in terms of the environment, the costs to your client as well in the longer term. So ultimately, that is the most sustainable way of managing these plants. So if you can do more with less, whether that's managing them in the early stages or preventing their establishment in the early stage of an infestation, that's going to be much more sustainable in the longer term.
Okay, thank you very much. I think this covers off a little bit in control with the soil pH, but David Hackett asks, on a site where chemical applications are prohibited, is it possible to have a form of control? I don't think necessarily goes. Unfortunately, we can't ask David to comment again, but I think that's leaning towards the likes of pH or other methods.
I think, you know, looking and I don't have practical experience of using this method, but I mean, in terms of physical management of rhizome forming plants, I just wouldn't recommend it. And I think it needs to be clearly explained to the client. There are derogations that you can use in order to use certain herbicides in certain locations, and it really does need to be explained clearly to your client that the likely long-term outcomes of management using physical methods for rhizome forming plants is likely to result in control failure in the long term, and it's going to cost you a lot of money. So I think it needs to be explained clearly to your client what the likely outcomes are going to be.
So managing their expectations as much as anything, really.
And ultimately, and this was a conversation I was having separately with people in the Nordic regions last week, they're really reluctant to use glyphosate. But ultimately, you've got to explain to your client what is going to happen based on what they feel that they need or want in the longer term. And it's part, I think, personally, it's part of your role to explain to them if they choose not to do certain things, what the implications to them will be in the longer term. And it's worth emphasizing to them as well, just because you're not using herbicides, that doesn't mean what you're doing is sustainable.
Okay, fantastic. Thank you very much. Right, we've got one more again, Richard Wheatcroft again. Is there any difference in the success of vegetative regeneration between equisetum and cut stems versus chopped or lifted root rhizomes?
I don't know what the data would be on this. I think basically, and I'm regressing to Japanese knotweed again, but effectively, when you look at the stems and leaves, the leaves are least likely to produce a new plant. The stems are a bit more likely. The rhizome is highly likely. So when you think about an equisetum plant, you know, the above ground parts of the plant are far less likely to spread the plant further if, you know, if they're moved around than the below ground parts of the rhizome. So I think that would be my general position on that.
Okay, slightly different tack on vegetative regeneration. Joe Mallet asked right at the end of the last webinar, and unfortunately we didn't get a chance to cover it off, so this is why we've set up this session today. Joe's got a project in a graveyard, and they've got most of the extensive knotweed now under control, so you can't talk about that, unfortunately, Dan. But they're now having an issue with field horsetail. what she's asking is, what low growing plants that won't affect the grapes could you suggest to dominate over the horsetail, preferably something native with flowers or seeds?
Working back from that, I think ultimately, whatever you plant in there, from a native plant perspective, it's going to be quite expensive, getting hold of those seeds, etc. In terms of the planting mixes specifically that we used for Japanese knotweed down at Taft's Well, Sophie Hocking, Complete Weed Control, and my PhD student will be publishing information on that early next year. So there'll be a bit more information regarding that. But in terms of immediate recommendations, I think getting out there and managing some of that above ground growth early in the growing season with a selective herbicide, a 2,4-D product, or triclopyr or whatever is most suitable for that site. I think that would be the first step towards getting on top of the field horsetail ahead of planting up later in the growing season with some native seed mixes. But bear in mind as well, when you're using these selective herbicides, a lot of them have a little bit of a residual activity, unlike glyphosate. So that means that you've got to consider that in terms of your planting. So get out there, get your herbicide applications done, and then leave a decent break of maybe up to a month, depending on the mix that you're using, to ensure that the residual activity, the herbicides in the soils, doesn't kill the grass that you then or other plants that you subsequently sow.
Fantastic. I hope that answers your question, Joe. And finally, Dan, you'll be glad to hear we're on to the last one. Al Mason asks, what options are there to control horsetail in hard surface areas, as this is often where problems crop up for them particularly?
Yeah, Al, this year has been a bit of an interesting one. There's been a lot of product changes, particularly certainly from what I could tell, looking around, because as I mentioned, I was doing a couple of projects on horsetail, and I wasn't actually managing it on hard surfaces. So I've gone away and I've done a little bit of research on this. So Diamond is a 2,4-D and glyphosate product that can be used on hard surfaces. So that was just one that I've come across. It's no endorsement of a specific product, but certainly for the hard surface work, Diamond is available.
Okay, fantastic. I hope that answers it, Al. Right, Dan, you're done. You're off the hook. So it just leaves for me to say again, Daniel, thank you very much for your time and your knowledge and sharing everything that you've so eloquently and informatively. It's been a great year. We've done 4 webinars. They continue to build in success. The reviews we're getting back are fantastic. It encourages us to do more, to be quite honest. So hopefully in 2021 we'll start putting more together and we'll roll them out at regular intervals. But what we'll do is get Christmas out of the way first. I think we all need Christmas, so we'll get Christmas out of the way and we'll worry about webinars later in the year. But for those that have tuned in, for all of the webinars you've tuned into, for all the questions, the engagement, the follow-up questions that have been offline to either myself or ICL or Dan, Advanced Invasives, we thank you for engaging with us. We wish you a Merry Christmas, keep safe, and we'll see you next year. Dan, thank you very much.
Thanks a lot, Barry.
Cheers, buddy. Ta-ra.